So I'm going to do some fault finding on a ty50 I've just finished, just looking at the ignition system. The bike's running but not as well as I'd hope, so I rather suspect that there may be something interrupting the ignition. So just go through some of the tools I could use and will be using. So just to discount it, there's this thing which is a strobe light. These are for timing engines. This is similar to this one. This is much more adjustable. So this one it really is set up for a car engine. This one you can adjust the sensitivity down, so it's much better for motorbikes, much more accurate. That's used with something like this. So this is a multimeter. We at C call these AVOs. AVO for current, voltage and ohms. But the more common term is multimeter. This is a really nice one, a Fluke one. You don't have to go to the expense of one of these. Even some of the most basic ones are just as good. The one thing to remind before you ever use a voltmeter is, especially if you're using on higher voltages like mains voltages, you always do two checks. One is a resistance check on the probe, make sure that they're actually conducting, and then once you've actually done the test on the voltage, before you actually take an action, you always double check the probes again after you've done the action. This is a spark indicator, right? So what happens is you put these on the spark plug, you connect your HT lead to it, and then you'll see the spark actually appearing here, so you don't have to remove the spark plug to check. Right, these are great. They're obviously difficult to actually fit in some motorbikes, especially if the tank is still on, but they work fine. And to be honest, the one I use most of all is an old spark plug. It's good, cheap, quick method of checking if you do have a spark. You can. The other thing I found when I was looking for a felt tip to do a drawing with is this thing. This is my temperature thermometer. Obviously it's not detecting a spark, but what it will do is it will, if you've got a multi-cylinder bike like my CB400 4, you can do a quick check on all the exhaust to make sure that there's hot gases going through all four of them, so you've definitely got a spark on all four. The other thing you need, of course, is the wiring diagram. So this is unfortunately my well-used one. I could really do with buying another one. What I tend to do is to redraw these with the actual colours on the wires. It just makes it much easier then, and I blow it up to that size rather than trying to look at this size, because I'm old and my eyes aren't absolutely fantastic. So that's a spare spark plug. Put in the HT lead cap. Just kick it over. I can't see any spark. We'll just try that one with the lights off though, just to make sure. Yeah, nothing. So now we go back to basics and we'll just work our way through the system. We'll start by measuring the primary side of the coil. So I've connected one lead to the connection to the primary side, and then we can just pick up on earth. We'll just double check that what the baseline reading is through the probes. Get about 0.4 ohms. So if we just pick up on earth anywhere, that's about 1. So it's about 0.6 ohms. Right, so we'd expect to see something significantly higher on the secondary side. So to measure the secondary side, the easiest way to do it will be simply to pick up on the HT outlet. And what this will do is it's a bit stupid. What this will do is we will be measuring through the primary coil as well, but that's very few ohms. So if we measure this in here, and we're getting around about 3.6 kiloohms, which sounds about right to me. We've got, you know, many turns of very fine wire, expecting quite a high resistance. So to me, that seems to check out. So we check the coil, and now what we'll do is we'll just check this circuit here, just to make sure that we don't have a permanent grounding either through the kill switch or the ignition switch. Now to be able to do that, we have to disconnect here, otherwise we'll ground through the points if they're made. Okay, so I've disconnected the wire that goes to the alternator. There's that grounding wire there. I measure now, right, I should remain at very high resistance to earth. The other end of the connector is to earth, and I have checked the continuity already. So if I measure here, and indeed we keep that good insulation to earth. So things haven't been going particularly well. I can get a spark, but I can get it by reducing the air gap, so the spark ignition coil. Right, it is a bit dirty. That shouldn't really do anything because it is covered in shellac. I do have 2 spares. One thing I thought I'd just point out is this is the cap which I actually have fitted to the bike. I've used these many times. This has an internal resistor of about 1 kilo. It's written on the side here. This is the typically the original plug holder, and this has an internal resistance of about 5 kiloohms, and you can buy 0 ohm caps. I do have some somewhere. Now they shouldn't prevent the spark from being generated. What they'll do is limit the current that goes through the spark. So the higher the resistance, the smaller or the less current will be going through the spark once the ionisation path's been created. Okay, so what these will do is tend to limit the damage in the points. What they'll also do as well is they tend to limit the noise in the system. So in particular, if you have changed the point system to electronic system, you really should be using resistor caps. If you can't use 5 kilo ohm resistor caps, then you certainly should be using resistor spark plugs. And I'm sure, like most of you all know, to read the codes, the B is to do with the diameter, the 7 is the temperature rating. So they lower the number, the higher temperature rating. H is to do with the depth of the thread, and S is to do with the conductor. So S is a copper conductor. So if you were to buy one of these with the internal resistor, right, it would be BR7HS. Okay, so if you are, just to repeat, if you are going to change over to electronic ignition, you really need to be thinking about fitting resistor spark plugs or resistor caps if you don't have them already. So that's the coil disconnected. Let's give it a measure. So first of all, check continuity at 0.2 ohms. Now if we measure to the wire, and we're about 0.9, say about 1 to 0.9 ohms, which, as I say, seems a little bit low. So if we get one of the new coils, we try this one first. So again, continuity 0.1 now, and if we measure this one, so that's about 1.5, so less than 0.1, so about 1.4 ohms. And if we measure the other one, continuity again. again at 1.4 ohms. So let's just check this one again, make sure I haven't done anything daft. So the camera just died. Battery life's not great on these things, really surprising. So we've got the old coil again, we're just double checking. So the two new coils, we're both getting around about the 1.3, 1.4 ohms. And on the old one, yeah, less than an ohm. So it is dirty, as you can see. I mean, the concern would be is that there's a short, so basically not all the turns are in play, and that's why we're getting a lower resistance. So we'll go ahead and change. We'll go to the new one. So hopefully you can see we've got a reliable set of gap on the contacts, and that's to be finished.